Guys, I'm not gonna lie, I just had a really good chocolate brownie. It was delicious. Well, good morning. And, yeah, chocolate brownie. Anyways, good morning. I hope you guys had a good night's rest. For those of you that are the night owls, I don't know how you stay up so late. I don't even remember doing that when I was your age, but good for you, man. You guys get to sleep in. All right, so we learned about Newton's third law yesterday. And Newton's third law, again, states that for every action, there is an equal and opposite reaction. Meaning if I push against a wall, that wall is pushing back against me with an equal and opposite force. If I go to jump in the air, my feet are pushing down and the floor is pushing up at the same time so that I can propel up. Other examples that you guys talked about was a rocket ship taking off. Another example would be like hitting something. If I swing a baseball bat and I hit the ball's coming this way and the bat hits the ball, which causes it to go back the other way. There's a ton of different examples of Newton's third law, also called the law of action-reaction. So we're going to look at some examples today that I recorded of my kids, and then I'm going to show you a cool demonstration of how this law applies in space too. And your assignment today, you'll just follow along with me as I show some of my explanations with my own kids, and you'll have to explain to me. I'm going to give you a couple of them as far as the explanations of what Newton's third law is there, but for everything else, you're going to have to write down and send to me what is happening to make it Newton's third law. All right, for our first example, we have my son Gunnar riding his bicycle. So Newton's third law is happening because as he pedals forward, the wheels are actually moving in the opposite direction, backwards, in order to get him to go forward. If you notice, the wheels are going in this direction in order to get him to go that way. So it's pushing this way in order to get him to go that way. One more time, let's see. Wheels are pushing backwards in order to send him forwards. All right, in this example, my daughter is bouncing a basketball. If you notice, she has to push the basketball down, and once it hits the floor is causing it to bounce back up. So Newton's third law, for every action, that's the ball hitting the ground, there's an equal and opposite reaction, that is the ball bouncing back up because it is hitting the ground. This one's one of my favorites. He has a leaf blower on a skateboard. You tell me what is happening to make this Newton's third law. This is your first one. Number one, Gareth with the leaf blower and the skateboard. How is this an example of Newton's third law? Please give me the action and the reaction for this one. One more time. Please try this at home. Here's your next one that you need to tell me. What is happening with Newton's third law as Gunnar is riding on the skateboard? How is this an example of Newton's third law? This is number two for you. How is this an example? Please explain the action and the reaction that is happening here. All right, for our next one, I have my three knuckleheads in our pond in their little rowboat. They are paddling, and the paddles are pushing backwards in order to propel them forward. If you notice that, actually part of Newton's second law is also in here as well. If you look, in order to get them to turn, Gunnar is paddling harder than Sophia is, so it's turning the boat. So he's applying more force to it, but the application of force is backwards in order to get them to move forward. So let's look at another example like that, and you explain to me what is happening. All right, here we have Gareth jumping off the boat, what is happening to the boat once he jumps off? Let's look at that one again. Once he jumps off the boat, what is the action and the reaction of him and the boat? We'll show you one more time. What is the reaction of his action when he jumps off the boat? What happens to the boat itself? Please explain Newton's third law with this one. All right, next one for you. Climbing a rock wall. How is it an example of Newton's third law, the three of them being able to climb up the rock wall? What is the action and what is the reaction? One more time. How are they able to climb up the rock wall? What do they have to do in order to move up the rock wall? Give me an example or explain to me how Newton's third law comes into play there. All right, so this one comes with a bonus question involved. So first off, how is this an example of Newton's third law with them bouncing on this thing here, okay? Like a slack line. How is this an example of Newton's third law? Bonus points. What other law comes into play? And please explain your answer when it comes to this handle breaking and Gunnar falling off. What other law comes into play with this handle breaking and Gunnar falling down? All right, Gareth running. How is this an example of Newton's third law? What is happening in order to get him to sprint forward? Explain to me Newton's third law in that one more time. Explain to me Newton's third law in order for us to be able to run like that. All right. How is Newton's third law in action here with jumping on a trampoline? What is happening? Please explain to me how Newton's third law is happening with jumping on a trampoline. All right, last one. This one may be a little tricky for some of you, but I'm going to see if you can actually get this one. I have a hammer that is hitting a nail into a piece of wood. If you watch it, this is in slow motion. What is happening to the hammer as it strikes the nail? What is happening to the hammer as it strikes the nail? How is this an example of Newton's third law? All right, so you have 8 examples that you need to explain to me in an email. Write it down, type it up in an email, and send it to me. 8 examples of Newton's third law in action. You need to explain to me the action and the reaction, how this is a part of Newton's third law. This will be your daily grade for today. So again, the first one was Gareth with the leaf blower on the skateboard. The second one is Gunnar on the skateboard. Number 3 is Gareth jumping off the boat onto shore. Number 4 are the 3 of them climbing the rock wall. Number 5 is the slack line with the bonus. What other law comes into play with Gunnar's handle breaking and him falling? That's a bonus if you want to do that. Number 6 would be Gareth sprinting in slow motion. How are we able to sprint? 7 would be how is the jumping on a trampoline an example of Newton's third law? And also the last one, the hammer. How is the hammer an example of Newton's third law? What is happening once that hammer strikes the nail? Now we're going to look at how Newton's third law works in space when there's no gravity there, how mass actually comes into play with Newton's third law?
Welcome to the International Space Station. I'm NASA astronaut Mark Vande Hei. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time. A force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Hello again. More basketball stunts that I can't do on the ground. At least not while getting this much hang time. All right, back to serious business. Got a basketball right here. Going to be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied, according to Newton's third law, by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So, I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force. We saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use two similarly massed objects. Joe and I have about the same mass. So Joe, get into a ball. I'll do the same. I'm going to face you this way so that I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him. Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth.
All right, your last question of the day. Why did it make a difference when the astronaut pushed the basketball versus him pushing someone, the other person? What made the difference there?